afternoon, guys. We are Iris Automation, building collision avoidance system for industrial drones to enable them to go beyond visual line of sight. It's a growing industry, expected to be $23 billion by 2020, almost doubling every year. Industrial drones will reshape major commercial industries. When I talk about industrial drones, I'm not talking about toy drones. These are drones which are 9 to 10 feet wingspan, flying at 30 to 40 meters per second, potentially hundreds of miles away from where they were originally launched, and beyond visual line of sight. They'll have a huge economic impact in industries like agriculture, package delivery, oil and gas pipeline inspection, and mining exploration, to name a few. But right now, drones are flying with just GPS waypoints. And regulators have said they will not allow drones to fly beyond visual line of sight unless they have an adequate sense and avoid system on board. And it is pretty simple. These drones will share national airspace with other manned aircraft and will be flying near infrastructure. Regulators are afraid of a fatal crash or damage to any buildings or any other infrastructure. Our solution, our sense and avoid technology, is the only system which can solve this problem. Right now, this is what drones see: completely flying blindly in their environment. No situational awareness, no understanding where they're going, except just a GPS waypoint. With an Iris solution on board, they're able to see the environment how a pilot sees in a manned aircraft. Using state-of-the-art computer vision and deep learning algorithms, we have developed software which will allow drones to do 3D reconstruction of static environment, detect objects beyond line of sight, be it aircrafts, birds, or any other dynamic object per se, and eventually do autonomous navigation as well. A lot of people ask us, why are we just using a vision-based system? Why not radar, LiDAR, or any other technology? There are a few reasons for that. We win on 4 main variables which are critical for UAV manufacture. Distance, we provide long-range detection. Low cost, because that's a huge issue for UAV manufacturers. Second, low weight and energy consumption. Any other system on board may not provide all these 4 things, which are critical for a UAV manufacturer to have if they need to fly beyond visual line of sight. This is just not a dream. Over the last 1 year, we have assembled a dream team to solve this problem. Our CEO was the first software engineer at a leading UAV manufacturer in Silicon Valley. Then he worked at NASA's Jet Propulsion Lab developing computer vision algorithms for the Mars rover. Our CTO spent time at Boeing's UAV facility in Australia developing software and hardware, and then at Spire Global, a Silicon Valley-based satellite company, developing hardware satellites and software for them. Our head of R&D has a PhD in computer vision from Andrea and had led R&D efforts and technical efforts at a major Paris-based startup in computer vision. Myself have worked at Microsoft, Barclays Investment Banking, Procter & Gamble. Our software engineering team has worked at major robotic startups in Canada. And we just finished Y Combinator in Silicon Valley. Our system, we already have an alpha product ready, which is flying on board on major UAV manufacturers as part of paid pilot projects. So it's actually starting to get results and starting to see how we can actually improve our product in the future. We have developed a very robust business model. We are selling our hardware at cost, which is an enabler to run our software. And recurring revenue through the software licensing model, charging $2,500 to $3,000 per year per drone from the drone manufacturers. We've already proved the model by getting more than $2 million in letter of intent over the last 4 weeks and are expected to sign $500,000 contract in the next 2 weeks as well. We are Iris Automation, building collision avoidance technology to unlock a $23 billion industrial drone market. We already have $2 million letter of intent in the last 4 weeks, are expected to sign $500,000 contract in the next 1 week, are about to close a $2.5 million seed round as well, and just finished Y Combinator in Silicon Valley. Thank you so much.
So we start seeing collision avoidance in consumer drones. Can you elaborate on how your solution is superior to what DJI is offering, for example?
Hello, I'm Alejandro. I'm leading the computer vision research and development at Iris. So this is a solution that always comes up, right? What is everyone else doing? So all the solutions that are out there are basically what we call bumper solutions. There are solutions that see like 20 meters away. And these are drones that fly at 40 meters per second. So you can easily see that by the time that you detect something, it's already behind, like you already crashed it. So this is a solution that is not, cannot solve the actual problem.
Maybe that's more or less the same question, but that I think the key issue. We are convinced that we have to move now from feature drone to smart drones and really bring on the platform smart technology. Sense is more or less easy. There are many military applications that are using those kind of sensors or vision technology to bring the sense of the sensor avoid. Avoiding is more complex because it means that there is a real brain behind the and as a child or a human has to learn that a door is a door to interpret that it's a door. You've got to learn to your system how to avoid the obstacles. How do you position yourself in that? Are you a sense and avoid solution provider? What can you tell us about this avoid brick? What kind of deep learning technology are you providing? Because definitely that's the key issue, avoid.
So I can start with a minor disagreement first. Is that the sensing part is not that easy for this kind of applications. You cannot like mount a radar into you cannot mount a radar into like a light drone, right? And the power consumption, all the constraints. So the sense is not that easy. So this is a key difference between like other possible solutions. For the avoiding part, we're like planning different stages for this. One of those is like first stage is just for some types of drones, just stop, make a pause, analyze the environment, and continue if you can. Second step is just going around the object that you're seeing, right? Not since you don't see and you don't have a complete map of the entire environment, it's just to try to go around it. We have already like a map, a 3D reconstruction of the scene, and try to find different paths towards the place you're going.
Sorry to go further and to complete the question, because there are different types of approach to do so. Whether you consider that you have enough calculation capability on the aircraft, on the device itself, or whether you've got to rely on what could be done in the cloud, because to make deep learning, do you really have, or do we really have the platform to embed that on the aircraft, or do you have to rely on the cloud?
So we started already with just part of the problem that is being solved with deep learning, and it's related to actually recognizing what kind of object is out there, to try to define trajectories and stuff like that. We haven't yet used deep learning to try to find best trajectory around it. Right now, like a big part of the solution is based on like 3D geometry, what we know about it.
Thank you so much.